So we're here to present some fabulous demonstrations by projects that are using and untethering the gig. Some of these are particularly meaningful to us because we have been working with these projects in our local communities. We're very excited to show you three particular projects that have rooted consequence in Chattanooga and Kansas City. So the first up is Gigabots. And who doesn't love robots and robotics? I've offered Jonathan Wagner from Gigabots $10 if he will do the robot while he's up here. But since the music's off, I don't think he's going to take me up on that. But we are going to learn significantly more about his project and the fact that it uses connectivity, gigabit connectivity, to devices to be able to communicate with gigabots. So one gigabot can communicate with another gigabot. It's a wonderful opportunity that through a web-based browser dashboard, kids can actually program using JavaScript ways for their robots to communicate with one another through a device or locally or remotely. So we're going to let Jonathan Wagner from Gigabots come up here and show us his fabulous Gigabots.
Thank you, Carrie. So I'm Jonathan Wagner from Kansas City, and I'm the founder and CEO of Big Bang. Thanks for having me here. I can honestly barely contain my excitement to talk to you today about the Gigabots. It's so exciting for me. Very quickly, since I don't have a lot of time, my background is game development, and I came from the game industry. I developed middleware for massively multiplayer online games, virtual worlds, simulations. From those of you who have worked with DARPA, I have also worked with DARPA. So real-time connected devices and real-time collaborative experiences are sort of in my blood. If I could talk briefly just for a second about my company, Big Bang, I think it'll make it very clear how that works in combination with the Gigabots. So what I'd like you to do is think back to 2009, and you probably didn't realize that this happened, but in 2009, the number of connected devices exceeded the number of humans using those devices. Now, if we just flip forward, There we go. Uh-oh, we flipped forward too far. If we flip forward just a couple of years to today, the number of connected devices is 8.5 billion. And if we look ahead just 5 years, that number is going to surge to 212 billion connected devices. And these aren't just new versions of your smartphone. They're not just new tablets. They're your cars. They're entire cities, and they're robots too. Now, we already have difficulty connecting all these devices. We have to find qualified, experienced software developers to do all this work. And we can barely do that now. How are we going to do that for the next 200 billion connected devices? Well, my hope is that people could use Big Bang, which is basically a platform that allows software developers to connect devices simply, easily, and reliably. So now onto the Gigabots. A Gigabot is robotics hardware, it's custom software and robotics firmware, and then it's a cloud service, which is Big Bang, to tie all the devices together. Let me unpack that for you just a little bit. The robotics hardware and the custom software work together to create a common API. We've heard a lot of talk about services this morning, and the combination of these pieces create a common API to expose the services that robots provide to us, which are things like sensors, touch information, distance information, and then also motors. So all forms of telemetry. These could be robots, but they could really be any sort of connected sensor. And then the cloud service provides them real-time event streaming and data synchronization. And this is the really exciting part. This allows devices to discover each other and to communicate with others. So robots can communicate with other robots, and they can communicate with other applications in basically any client that's part of the Gigabots network. And this is going to allow really, really interesting applications like swarm robotics, collaborative robotics, or an enormous remote sensor network. So currently, the Gigabots run on the LEGO Mindstorm's EV3 platform. This is an extremely popular platform for K through 12 education. Just to give you an example, in the Kansas City area alone, there are over 10,000 students that participate in Junior First Robotics, First Robotics League, and First Robotics. And so it's a very popular educational platform. There's lots of students that have these kits currently and are using them to create robotics. These particular devices use pure Wi-Fi connectivity. All they need is a high-speed, low-latency connection to the internet. There's no host computer required, so that means that if students want to use these in an educational setting, they don't need a specific computer. All they need is a Wi-Fi connection and a web browser. And just as an example, if you saw the on-demand drone delivery of Wi-Fi yesterday, I brought one of the Gigabots out in the parking lot, and they were able to connect to the drones, and I was able to control the Gigabots via the drone network. So again, no special connectivity required. Even other robots can help them out. And finally, this is a low-cost addition to their existing hardware. The schools have already made investments in this, and to turn your EV3 kit into a Gigabot requires the addition of a very inexpensive Wi-Fi dongle and a compact flash card with some custom software. So very, very low cost and very easy. The Gigabots software, just for some technical details for you, is based on an open source alternate firmware called LEJOS. It's non-destructive to the robots, so it doesn't require flashing them or repurposing them as a different type of robot. If you pull out the little firmware card, they revert back to their standard firmware so they can be used with other classroom experiments. We've also created a dashboard, which I'll show you here in just a minute, that allows you to see real-time telemetry from the robots and control them. And I think one of the most exciting features is the ability to program the robots directly from the browser using JavaScript. I think this is really so important for students in education to have exposure to programming as young as we possibly can do it, and to give them the opportunity to program these devices simply and easily without messing around with IDEs, without installing software. So in my opinion, being able to program them directly from the browser was a huge win. So now on to the demo. I think W.C. Fields said never work with children or animals. I think if he would have been around for robots, he probably would have said that too. But I'm going to give it a try. See if you can see the dashboard there. Maybe I have to move it to a different screen. There we go. This is going to make this a little difficult. Let me sort of orient you to the dashboard. This can be used to connect to any Gigabot in the network. Right now, I've selected Gigabot Prime, who's the guy on the right here. He's sort of our mascot, and you've seen him in a variety of pictures places. We can get real-time sensor information from him from his infrared sensor as well as his touch sensor. And students can use these controls to control the robot quickly and easily for prototyping devices. So, for example, I'm going to modify the speed control, or actually over here, for the robot, and then we should be able to move him around a little bit, hopefully. Yeah, there we go. He's having a little difficulty on the carpet there. Now, also, since this device is since this is a web application, I've got a tablet here that's also connected to the Wi-Fi network, and I can go ahead and control the robot from this network or from this device as well. And one thing I want to show you is that the interactivity and the collaboration is not just for the robots, but it extends to the applications that are part of the Gigabots network. So you'll see that I'm controlling, I'm making some adjustments to the speed control on the motor D here, which is his head, and I can go ahead and turn his head back and forth in real time, and I can make those adjustments here from my tablet. I could collaborate with another student in another school, and we could control this robot collaboratively. A really interesting feature, I'm going to get down here with the robots, this is the part you shouldn't probably do, is that we've also been able to program some really interesting behaviors for these robots. So Gigabot Prime, being our mascot, is he likes attention. And so I've given him a behavior that if I touch his little touch sensor here on his head, he's going to do a little happy dance for you. I don't know if you can see that out in the audience, but he's very happy about that behavior. And I also have this other robot whose name is Jeff, kind of inexplicably. The guys that are helping me out named him Jeff, and he's actually a robotic coffee mug. And he also has a touch sensor, and I'm going to go ahead and trigger that now. And you'll see that Prime doesn't like me to give attention to other robots, so if I activate his touch sensor, he's giving me this head shake and little mad noise. Now that's a really simple example, but that shows you sort of the really how simple it would be to create interactions between these connected devices. Let me go ahead and switch back to the slides now. And one thing I'll point out is that the little happy dance that Gigabot Prime did for you, this is basically the JavaScript code that's really required to make that behavior. It's very, I think if you look at it here, I think everybody in the audience can see how simple it is to rotate one of his wheels and then rotate it back to 0, rotate his other wheel, rotate back to 0. That's the core of it, but that's just sort of an example of the API that we're providing for students. And then finally, the future of Gigabots. I'm really excited about the possibility of bringing this to other low-cost educational platforms and other platforms that are used by other communities, such as the Raspberry Pi or the Arduino. And my goal really there is to expand the community from just education to hobbyists and makers. I think that low-latency video, streaming video, would be very exciting for this platform. I think it would really enhance collaboration between classrooms. And finally, the addition of code sharing and collaboration, I think, would also be a really fantastic feature for this platform. One thing I also have to mention is that everything that you've seen today is being piloted next month in the North Kansas City School District as part of their summer robotics camps. These kids are going to be constructing a Gigabot from scratch. They're going to be creating it, turning it into an internet-connected platform. They're going to be programming it, and they're going to do that all in a single day. So thank you very much, US Ignite. I'd like to thank the Mozilla Gigabit Community Fund for sponsoring the Gigabots and US Ignite for having me out here, and thanks a lot.